Good afternoon, everybody. Thank you all for coming. We're going to be doing the hands-on session for invoking AI microservices with FHIR. My name is Brad Genereaux, and I am, by day, Global Lead for Healthcare Alliances at NVIDIA. I've been involved in the standard space for many years. I have been chair of HL7 imaging integration while we developed FHIR resources for imaging, including imaging study. I've been involved in DICOM. I've been co-chair of a number of working groups, including the DICOM Standards Committee. I'm involved in IHE, currently the co-chair of Radiology Planning Committee. I've worked in hospital IT. I've worked in at a PACS vendor, doing zero footprint viewers and AI platforms and technology. You can find me on LinkedIn and X at Integrator BRAD if you want to look me up. And yeah, let's get started. So this morning I talked about the power of microservices, and as we kind of think about large language models and other AI solutions, bringing this back into how we can leverage these inside of our healthcare applications. I've been involved in hackathons and API development for many years, trying to understand the best practices for developing APIs and understanding, how we leverage REST and, representational state transfer. I've been a fervent believer in what's called the 5-5-5 rule, which is 5 seconds to find the documentation, 5 minutes for a hello world application, 5 hours for a fully working proof of concept application, as a general guideline for developing solutions. And so finding myself in the deep learning space and now in the large language space where there's a lot of prep work, there's a lot of setting up of applications, there's a lot of stuff that's necessary in order to leverage these types of technologies in our solutions. And super excited about now that we start to see these technologies being transformed into APIs so we could essentially consume alongside everything else that we're developing. So I'm going to be talking about that impact on healthcare, focusing on large language models, but we'll talk about a few others that my team at NVIDIA has been developing. We'll kind of walk through those with some fun examples. We'll pull in some FHIR, we'll work with FHIR, and then call it a day. For this, please, if you have a laptop, pull it out. Let's do this together. It's super fun, it's super easy. We're not going to really code. You're welcome to, and we'll provide the code if you're interested in connecting it from the command line or inside of your application or on Python or what have you. But nothing really is required except for a browser. No installs. You don't need an account if you're just going to play with it on the web. If you're going to call APIs, you need to sign up, and it's free to sign up. I have this, there's a standard disclaimer, right? So just be aware that these models will generate responses based on what it's learned, and they might be inaccurate, it might be indecent. I haven't had that as an issue when doing these demos so far. But so many risk and by using the outputs of this. So don't upload confidential data, yada yada. So just be aware of that as we kind of use this. So the use case that I'm going to step you through first is imagine if we're going to create a brand new biopharma company. We're going to create a drug to treat liver cancer. We're going to develop a treatment plan. We're going to create a new drug together. We'll do some clinical trials work, and then we'll create a promotional image at the very end. And we're going to use this through generative AI and APIs to help us do this. And then the second part that we'll walk through is we'll do this leveraging FHIR messages. The first part will be without FHIR, just to kind of get acquainted with calling these APIs and how we might consume it. So as I said, kind of 4 steps. We're going to use generative AI to create a treatment plan. We're going to use generative AI on proteins to create a drug and molecules. Then we'll do some computer vision, and then we'll do a generative image. That's our walkthrough. So to do this, follow along. open up a web browser to build.nvidia.com. All right, so I'm going to exit out of my deck. Oops. Well, I'm going to balance my laptop there, but all right. So, all right, we're going to open up our web browser to build.nvidia.com. And how this interface works, it's all of the generative models here are grouped together under various categories like reasoning, visual design, around industries as well, for healthcare and gaming and industrial use cases. We're going to start out, as I said, we're going to create a liver drug program by first understanding how we might go about treating liver cancer. So we'll step over into our reasoning. Actually, under the trending now, well, you're going to use the Llama 3 model here by Meta. But you can see that we've actually got a ton. So if you actually would prefer to use Google's Gemma, which there's a great talk just about 20 minutes ago on leveraging some of Gemma's work. If you'd like to use Mistral, you can. I'll use the Llama 3 model. That's the one that I've been experimenting the most with. The 70 billion model. Once I'm in here, you can see that I can, on the left-hand side, interact with it directly. If you want to do stuff from your application or from your command line, you can do so here on the right. You can see the code that I would call, whether you want to do it in Python or a Node or in Shell, or if you're going to pull down a Docker, you can do that. But to do this on the right-hand side, you need to grab an API key. You need to sign in to do that. But for the left-hand side, we don't need to sign in. We could just start interacting with this directly. So here, I'm going to say, how would I treat liver cancer? Or maybe better, what are the steps to treat liver cancer? I got my start at the Ottawa Cancer Centre up in Canada many years ago, so I'm very familiar with the steps, kind of end to end. But essentially, it's going to be diagnosis. We're going to stage the type of cancer. Understand the cellular types, and then we'll move into the interventional part where we might do surgery, we might do radiation therapy, ablation, and chemotherapy and immunotherapy as well, and then all the way through to treatment and follow-up monitoring. They might be eligible for clinical trials, but I can really quickly get all the information that I need for these types of questions just by having a conversation with this. And I can continue on and say, tell me more about chemotherapy options. And I should be able to learn about liver cancer chemotherapy options. Let's see what happens. Different types of drugs that I might use, including, I'm going to highlight this, Fluorosil, which is one of the drugs that we would use to treat liver cancer. So it actually knew the context that I was asking the question, and I'm building upon it. And what's really neat is that you can actually see here on the right exactly the type of queries that I'm making. So as I'm kind of building this on the left, you can see how I might embed that in my solution there on the right. Okay, cool. So now I know that I will build something around chemotherapy for my patients. So now we're going to go back to, and you guys are all following along. Any questions so far? Everyone's in the website okay? Thumbs up? Slower. A little slow? Generating. Okay, maybe it's, we're, maybe it's okay. No. All right, let's say it's the Wi-Fi network. Okay. So next up, let's look at drug creation. There's a number of models in the drug discovery space that are up here that's available, which is really interesting, around creation of new drug molecules, taking molecules and finding how they might bond with proteins or interact with proteins or counteract proteins. So for example, taking the spike protein from a COVID molecule and crafting a protein that would counteract that is an example of something that you could do with these tools. MolMem allows me to take an existing drug molecule and make improvements on it. And so there are a number of different examples here that I could take. For example, I'm going to take floxuridine, which I flagged from our chat with Llama a minute ago. And you can see that there is the chemical compound for floxuridine. Now I can set a variety of parameters, like how many new drug molecules do I want to create. What am I optimizing on? I'm going to take this molecule and make it better, make a new drug, and I'm going to improve the property of QED. And there's a couple of different properties that I could choose. I can look at how do I want the similarity constraints. But these are things that, again, on the generative front, just parameters I could use as I'm crafting my new potential drugs. And I run this, and you can see that I've got a whole bunch of new potential drugs that I might use to treat liver cancer. So this is something that biopharma companies would use as they're searching for new compounds rather than essentially trial and error. So cool. Let's say we're going to take one of these molecules. That one looks pretty good. That we'll take that out to market. So now I've got a drug. I've got a treatment plan. Now let's run clinical trials. So we're going to test this drug, see how well it performs. We're going to get tons of imaging studies coming from all different hospitals. And now I've got to process it and work on, for these patients, is my tumor getting bigger? Is my tumor getting smaller? What is the impact of my drug running these clinical trials? So there's another model here called Vista. So if you go back to the healthcare side and you scroll down, there is this Vista 3D model. When I open this one up, we're going to open this one up in full screen mode. So here, open full page. This one might take a minute or two or a little bit longer because I am pulling a CT study. Here, maybe I will just refresh my page just to be on the safe side. See if that makes it. Okay, there we go. Okay. So you see here that I've got a CT study on the right, and if you use your mouse wheel, you can scroll through the stack. So this is CT study, right? Slice, 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 slice of the body at 0.5 millimeter increments. I can see it in coronal or sagittal views if I want to. So this way or this way, which a sagittal would be, it's this side of the body all the way through, right? So here I'm looking at livers for my liver cancer. I can use computer vision to go through and say, segment the liver for me so that I understand, for this particular study, what is the liver and then the liver lesions would look like. A manual segmentation process, if someone were to go through and do this slice by slice, takes about 15 to 18 minutes. Because of, slice 1, slice 2, slice 3, going through the body, making a circle or whatever shape the liver is, liver-shaped, across the entire, all the frames, and it could be, 150 frames or so. But you can see that I can get this back. My explanation takes longer, it seems, than the actual segmentation. So you can see that I've got the liver there, segmented. Maybe I'll look at it in the axial view. Oops, you should be able to see the liver there. Taking up the body there. If I actually, just for fun, if you don't supply a class label, you could actually run this whole thing and it'll segment something like 140 different structures in the body, every vertebrae, every rib, a lot of the brain system, the cardiovascular system. It will do some of the major muscle groups, abdominal organs. So each of these is associated with a label. In the raw data, you could actually see that. So my world of medical imaging really kind of covers that. So maybe if I look at if you can see the spine in one shot, would be like, so you can see there. So yeah, so you can see all the different all the different vertebrae there, and the raw response has all the labels of each one of those. So cool. Okay, so we did a treatment plan. We made a drug. We ran a clinical trial, and now my drug's approved, and hooray, fantastic. Let's create a promotional image of of my new drug. Everyone's seen, the commercials. So under visual design, this is kind of like the last part. So there's a number of different libraries here. We'll use Edify Image, and here I might do liver cancer, treatment, chemotherapy. You just give basically a comma-separated list of keywords that we're going to craft some images from. Let's I don't know, healthcare, and we'll run this. Let's see what happens. This is where I always worry about indecent. So let's see what happens. It takes about 15 seconds or so. Oh, okay, there you go. All right, so some are okay. I've got the shiny liver. I think that's pretty good. I don't know what's happening in the bottom right with pills that are hooked up to the liver somehow, but okay. But so you get the point. I can use all kinds of different generative solutions. These are all API calls, and everything that I'm doing here, I can you can actually see what that looks like, and I can craft these from an API perspective. So that's kind of life on that side. It makes it really easy as a developer to be able to leverage this and not having to really think about where's the server, what's how do I stage it? How do I secure it? How do I run it? This is running up in a cloud. It doesn't matter where it runs. What's really great about these containerized solutions, you could, if you have it, if you have a data center at your hospital or at your development shop, you could run it there, or you can just pay a couple of bucks and run it up in a cloud somewhere. Okay, let's now have a look at FHIR and connecting up into this. So we're going to now kind of pivot to large language models and start to experiment on this side. So I open a bunch of tabs here, so I'm going to actually be jumping back and forth here a little bit. So let's go back out. I guess I don't have a really good way of, I don't have a really good way of giving you the links, and I don't really think you want to type build.fhir.org, blah, blah, blah. But if you want to just, grab your own FHIR message, I use FHIR allergy example, and I think that's the first. Oh yeah, I'm not a robot. I think this is the one that I had grabbed. This is for cashew nuts. Okay, yeah. All right, so this is the one I'm going to use. So that's how I found sample FHIR message, but this is the one that I'm going to work with. I'm going to go through. Actually, I guess I can hit raw JSON and save myself a little. So I'm going to just copy this out. A FHIR message. You can see here that it's for an example patient. That it's for cashews. We got the SNOMED code for it. We can see things like the first, or what is the reaction? So they get they go into anaphylactic shock, and they also get hives. We can see that it was first noticed back in 2004. So we take this. We're going to go back out to my llama model here, and again, you could try this out in whichever language model that you choose. And I'm going to say, for the following FHIR JSON message, what is my patient allergic to? Now, every time I was doing this last week, I would forget to press Shift-Enter. To get to the next line rather than enter, which will just submit this, and it says, I don't see a FHIR message. So we'll paste that there. And so I can, very quickly it comes back and says, according to this message, the patient's allergic to cashews, so great. And then it provides the evidence of where it got that from. It sees that there was a coded element that refers back to cashew nuts, which is, pretty good. I like that. I know that it didn't hallucinate because it's showing me where it derived that information from, and then I can now start to ask questions like, what happens if my patient has cashews? Recognizing that it already has a state. Oh, what is this? Select the images that are most related to the provided sample. And it's a picture of a pot? I've never had this before. This? Clearly, I chose, there's a pot and I chose plate of food rather than the giraffe. Okay, that's interesting. Okay, so what happens? So according to the message, the source of truth, the patient would have an anaphylactic reaction or hives. And they've had it in the past. And it even mentioned that it happens within 15 minutes of consuming cashews. So yeah, it's crucial to avoid exposing them to cashews. That's a helpful thing, right? But now I can start to even say things like, what should I do if my patient has cashews, right? So, or maybe I'll even say, my patient just ate some cashews. Should I do anything? I don't know what's going to happen. Oh. Okay. The panda is alive and unable to fly. All right. That is very strange.
I mean, a real human wouldn't have to ask it.
Oh, no. It's very, very melodramatic. Take immediate action, call emergency services, administer epinephrine if I have it, while waiting for help, keep them calm, do not delay, anaphylaxis can progress rapidly. So it really is thinking through, based on what it already knows, what we've already had, already done. And let's see if I can try to trip it up and say that the patient also had a glass of water. Is that okay? Let's see. And I'm now like going off script. Okay, fun. All right. I assume you guys are also getting those prompts. Find the panda. Okay, cool.
We probably all show up with the same IP address.
Yeah, I think that's probably what's happening.
That's a common thing that happens.
Well, also, I mean, Google's also like the search engine is having an issue as well. So, okay, yeah. So it says water's not going to be an issue. So that's fun. Okay, cool. So something very simplistic, right? Which is I'm using coded terms. I have a pretty simplistic use case, and it does a really good job of just understanding what's going on, and I can have a conversation and go off on different directions, and it doesn't seem to be phased whatsoever. What's really important here is these modern large language models have guardrails, so that I can't really try to do something that's going to, potentially cause harm. I mean, of course, if I really, really try hard, maybe I can find some way. But there's a lot of smarts put in on the input and on the output to make sure that we're not veering off into hallucination land to any great extent. Okay, let's do something a little bit more complicated now, which is we're going to take this diagnostic report. And you can see here, it's free text. There is a coded term here, which is nice, but there is definitely a lot of free text there as well. So we're going to take this entire diagnostic report as FHIR. We're going to come back here. The one thing that'll say that we need to do is let's just reset the chat so that we don't think that this patient also is allergic to cashews. So we'll hit reset chat. So, start the conversation over again. Based on this, how did I get here? I think the best way to do it would be FHIR diagnostic report DXA, because it's the DEXA scan, and that should take you to here. And then I'd like the JSON format, and I would like it in raw format. Yeah, so that's, I think it looks like it's a different report, actually. Is it? A little bit different. We'll take this one. I don't know, for fun. What's the worst that can happen? Based on the following FHIR message, or message, let's say. What is my patient diagnosed with? All right, so I could take that, send it. Don't pick the hamburger. I like how it has multiple kinds of hamburgers, two stack. It's awesome. All right, based on this FHIR message, patient's been diagnosed with osteopenia, typically characterized by a decrease in bone density, but not osteoporosis. So the patient is potentially on their way to developing osteoporosis, and they said that it's within the range of concern a little bit. So I can now say things like, what should I do for my patient? I don't know. Okay. So based on this, the report suggests that the estimated 10-year probability is less than 10%, so considered low. You might consider things like lifestyle modifications, fall prevention, so doing some patient education, some monitoring, consider supplements. Okay, so those are all, it sounds like good advice. What kind of supplements would I give my patient? And can you provide appropriate evidence that those supplements are effective? Again, I'm going off script. I don't know what's going to happen. I guess I know that's going to happen. Okay. Okay, so it's going to pull through, and it's giving me some references to some journals as well on it. So that's nice to see. And how much would I give them? So calcium, vitamin D, etc. Let's just see if we can find something in the free text of the report that we can see if we can, that's not in the coded section. I guess it did do a pretty good job. But let's just see if there's something that we can ask it. I don't know, the relative fracture score of my patient is 2. Okay, what does that mean? I don't know. So, I mean, the point is, though, is that we've got something that we can, build all kinds of applications around. Maybe this is something that I could connect into a patient portal. Maybe this is something that I can connect into a patient follow-up regimen. Maybe this is something that I could leverage for the nursing staff or the patient education team for the patient. There's a lot of different practices that I might use this. Maybe this is something that I would offer to referring physicians from a specialty clinic to be able to follow up and dive a little bit deeper based on the data that I would provide about my patient from FHIR to be able to drive this. So that's it gives you kind of a sense of what we could do in that one direction. The other direction. And Diego was very kind to me this morning to remind me that it's not generating FHIR, but something that looks like FHIR, but that's okay. Can you, actually, let's go off script again. Can you generate a FHIR message, a FHIR JSON message of an observation, of a FHIR observation reflecting my patient's diagnosis? Let's see what it does. Okay, so it's generated a FHIR message for me, which is, oops, let's see if we can have a look at it. It's pulled out an observation of a diagnosis. It used a reference to a SNOMED code. So in the code for the observation, did a reference for my patient. Actually, I wonder, is it the same? I should check that, just out of curiosity. Is it PAT 2? It is. Okay, so fantastic. So it actually used, references that I already knew about the patient, and pulled in a couple of reference ranges. It was an abnormal finding, and it actually provided the relative fracture risk. So it does have, is this compliant FHIR? I think we'd have to check, against what version of FHIR that we're using. If it's R4, R3, and do some validation work. I think that's, some of the conversations I had this morning over at the fireplace is that maybe we do this in concert with a validator and are cycling through, which I think is a really interesting idea. But we can already start to do this construction. This is Llama 3 out of the box. We didn't do really any sorts of customization to it. We didn't teach it anything really about FHIR except for just what I provided, but it had a lot of context already with FHIR itself. So we did it. We tried out various generative models. We used an API to do it. We tried working with FHIR, passed in FHIR messages and asked it questions about our patients. We generated FHIR and did some spot checking to see was it in the ballpark? Is it pulling things that are originating from my original scenario, and it has. And as a place to start, we can now think about how we might connect this into our whatever development work that we're happening to do. So I think that's all that I had on the docket today. I think we're going to do questions first. Yeah, are there any questions? All right, here comes the microphone.
The reason I feel that everyone's kind of iffy with LLMs is that there's something of a leaky abstraction. Like everyone on the other end always has to keep in mind that they're getting stuff from an LLM to get maximum use out of them and to minimize the risk of hallucinations. Do you know of any current work to reduce that disconnect?
What I've seen so far is when constructing applications to wrap whatever prompts or whatever questions with additional background information that the user doesn't end up seeing. So what I mean by that would be, for example, you saw that I was prepping it and say, hey, I'm about to give you a FHIR message. So it knows that that's the frame of mind that I'm thinking about. What I might do is, if I don't know if I'd make a FHIR understanding tool or something like this, but I would kind of prepend that without someone actually seeing that. I'll say that's a fairly lazy way of doing it, a very hackery way, and that's what I tend to do more of the hackery. There are techniques like Laura's. I'd say regs are probably a little bit too much. I don't think you need to go as far as that to provide some additional context at runtime or at runtime or at start time to kind of guide it. But those are the ways that I've seen, kind of like easy, medium, and then heavily customized. But no, that's a great question. It definitely feels like I'm very staccato saying, I'm going to do this, I'm going to do this, I'm going to do this, and then I am getting a result that I like because I'm not really giving it as much opportunity to go off the rails. So, and that could just also be because I've seen it go off the rails with like Llama 2 and earlier models, and maybe not as comfortable. I want to make sure. Maybe I didn't need to do that. I just wanted to make sure it worked today. So, no, good question though. Any other questions? Everyone had this work on your laptops? Like no issues? Thumbs up? Thumbs up? Awesome. Fantastic. All right. Well, let's just kind of close out my slides, which is, so we did this all from build.nvidia.com. We're really doing this to make it easy to consume, to be able to compare these different models. As I said, we had models up there from Llama, from Meta, from Google, from Microsoft, from Mistral, from image generation, from some of the best and brightest in drug discovery, really just to provide a means to get access to it, to really make it straightforward. As I said, the 5-5 rule to me is what's so important, and it's absolutely incredible that it's just a place to start. So wherever you start in these models. Oh yeah, hey, a question.
For people who aren't here, do you have a tutorial on how to do this?
I do. It's not public, but I do have a tutorial that I could share.
I wonder what uses the site if people don't have this
Well, the
instruction.
narration. Yes, exactly, and that's exactly why I had created my tutorial, because it's hard, from a healthcare perspective. You don't. I mean, that narration, that journey, I think was so important. I know they're making this available. I guess after 6 months, if I recall, to the public. It's a long time from now. But yeah, I'll think about that. Well, we could talk about it offline too, I think.
Uses the site
Without the tutorial, yeah, exactly. I really like that idea. I will dig into that. Thank you so much. Okay, we walked through calling APIs, how to call them, how to connect them from your applications. And I didn't really talk about it too much, but with all of these things, I mean, the models you can pull them, like the raw models from Hugging Face is one place where you can get them. You can get them through services like NVIDIA and others are doing. But I say the most important thing is get started. I mean, the technology's here. It already is transformative. So if you want to reach out to me, you can find me, as I said, Integrator BRAD on LinkedIn and X. You can take a picture of that QR code. That'll take you to my Blink. Or I've got a smart card you can tap if you want to connect with me after the talk. I'm here to the end of day today. I'm heading out tonight, so I won't be here tomorrow. So if you need anything or want to chat about stuff, today's the day, or you can just reach out to me afterwards. And with that, then, any other questions? Oh, one more.
Thanks for the talk. Just wondering, like, any particular reason you used Llama 3? And if none, like, how did you find it compared to, like, the other models? And, like, if there's any, like, particular areas that specific models excel in compared to the others?
Yeah, no, great question. I chose Llama 3 because last weekend, we went general release with the Llama 3 model up on the NVIDIA website, which means that we've tested it with all sorts of different computing configurations, whether it's a gamer card all the way through to enterprise cards. A lot of the other ones are currently in a mode that it's very specific cards. So I just picked one that you can take and you could download on pretty much any sort of compute accelerated infrastructure wherever you wanted to run it. Just for fun. Again, I've not done this, so I don't know if this will be terrible results. But let's just for fun try another one. Let's try. Just to be fair, let's do another large model. I think Mistral Large. I don't know how many, let's see. What's really great, by the way, if you're interested in digging into the different models, we have these model cards, which talks about like where the data comes from, responsible AI, and a lot of a lot of the work that NVIDIA is doing in this space, what we've tested it on, benchmark data, and kind of a lot of those details around that. I can ask my question in French. Let's just try, given this FHIR JSON, this is the allergy one again, message. What is my patient allergic to? Let's see what happens. Ooh. Oh. Wait, did I give the wrong message? I did. I was like, it said there's a patient allergic to anything. And it's because I gave it the DEXA scan. How did I do that? Here, we'll try that again. Let's just clear the input. Oh, can I do that? That's so good on that. Let's try it again. Given this FHIR message, what is my patient allergic to? Okay, so Mistral says the patient is allergic to cashews, so that's good. And then it tells me that the code came from SNOMED and some background. The allergy is categorized as food and of high criticality, noted in 2004. That's pretty decent. That's really good. And just for fun, why don't we do one more? So, I mean, the bottom line, I guess, is that what's really, I mean, the industry, the community, the ecosystem are all coming out with new models every week. Let's try Gemma. Given this FHIR message, what is my patient allergic to? And see what it says. Maybe this is the 7 billion, though. Maybe it's not as good. No? Okay. So you can see the different flavors, different responses. I don't think that I'm at a point to really say, oh, you should use this one over that one. I think you know, to make that determination, you would do, you know, tests based on your use case, based on the data that you have, and to really get that really good sense. And I think that over time, we are going to continue to see, you know, tens, hundreds of these models, bigger models, you know, more, you know, refined models. One of the things that's really important, at least from my perspective, you'll see that we're actually, for these language models, we're using the same API from OpenAI, so that you shouldn't have to change your application to use different large language models. So that if you wanted to, you know, let's say you base it off of one and you want to try another one and see how it performs, you shouldn't have to rip and replace and rewrite code and do a whole bunch of different stuff. And so the API remains the same, but the models you can change out and try different configurations, different parameters, and different models from different consortiums. So, okay, anything else? Yeah.
Circling back to your earlier answer, you were saying the Llama 3 70 billion can run on pretty much any hardware. I've been doing this testing recently, but we tried a while back with the Llama 2 70 billion, and I seem to recall that needed pretty beefy GPU, or at least GPU memory to run.
Yes. Yeah.
Really change that, or are you running like 70 billion quantized on all your hardware?
No, that's a really good point. So it's funny because it says any hardware. The difference is, so you need to be able to host the model inside of GPU memory, and for the 70 billion, you need to have something like, I want to say it's like at least 40 gigs of GPU RAM. It's a lot, yeah, exactly. And so the 7 billion one can fit into some of the smaller cards. All the other ones that I showed, the Gemma, the Mistral, they're all on very specific cards, A100, H100, and that's it. And just because we haven't done the acceleration work yet before we made it general release. But yeah, there's still restrictions, and they did put an asterisk at the end. Any GPU, asterisk. So yeah, it does have to fit into GPU memory in order for that to work. But yeah, good call out. Thank you. Okay. Anything else? Like I said, I'm around the end of the day. You can always find me up on LinkedIn, bgenereaux@nvidia.com. I love to chat about this stuff. You know, the work that you guys are all doing, that we're doing, is transformative for everybody. So thank you very much. Enjoy the rest of FHIR Dev Days.